discrete random. A random variable is just something we've deduced from an experiment which is random. So for example, flipping coins on the right hand side. Random variables are represented by the uppercase letters of the alphabet, so it has to be capitalized. Lower case alphabets are usually for the probabilities, not for the variables themselves. So that's the reason why when you write it, you write probability of x equals to x. So capital X is the random variable, x is the outcome that we want. Discrete random variables are when you have countable integers. So when our values of capital X are whole numbers. You can't do anything that is non-whole numbers with this. There is a thing that we look at later for that. Just really quickly, you should know about this anyway. Probability should be between 0 and 1, and the sum of the probabilities should equal to 1. A motorist travels along a main road in Brisbane. In doing so, they must travel through 3 intersections with traffic lights over 2 kilometers. The probability that the motorist will have to stop because of a red light at any intersection is 2/5. Let x be the number of red lights encountered by the motorist. So A. Use a tree diagram to produce a sample space for this situation. So remember, with tree diagrams, you write down the probabilities of it happening and it not happening. So you either have, well, technically there's also a yellow light, which is hilarious, but anyway. We'll presume it's just a red light and a green light. So red light, it's 2/5. Green light, it's 3/5. Because that has to add up to 1. Then you just write out all the branches of what happens each time. B. Determine the probability of each outcome. So simply find them all right there. Remember, these are all independent events. Just because you stopped at the first traffic light doesn't mean you'll stop at the next one. So you have to multiply them. Alright, C. Find the probability distribution for this random variable. So what you need to do is we need to know by number of lights, a number of times we stop. So we either stop no at no point in time, once, twice, or 3 times. So if we stop every time, it's red, which is 8/125. If we stop only twice, that means we have 1 green light. So we're looking at this one, and that's it. So it'll be 36/125. If we stop once, that means we have 2 greens. That's this one, and this one, which then gives us 54/125. And the last one, if we don't stop at all, that's 27/125. Alright, D. To test whether or not this is a probability distribution, simply add them. Now I did this just before and I got it wrong, so hopefully I get it right this time. So 81 plus, what's that, 44? Yep, so that's 125/125, which is 1. So therefore, yes, it is a probability distribution. Alright, state giving reasons whether or not the following represents a discrete probability distribution. Well, first things first, we can't have negative probabilities, so no. Then look at the second one, we need to add up the probabilities. These values, whoops. These values on the top actually don't matter, we just have to add the ones on the bottom to see if it adds up. So 0.01 plus 0.32 plus 0.52 plus 0.15, 0.33 plus 0.67, which just gives us a 1, so 40x. Alright, third one, 0.2 plus 0.1 plus 0.2 plus 0.3, that gives us 0.3 plus 0.5, which is 0.8, so no. Alright, B, a random variable x has a probability distribution like so. Find the value of the constant b. All you need to do, remember if you're at the bottom, it gives you a 1. I'm going to write the b slightly different. And it's equal to 1. So that's a 1, 2, 3, 4, 5. So then b is equal to 1 over 5. A coin is biased so that there are twice as many chances of it landing with heads up. The coin is tossed 3 times. So then the probability of one head would be twice as many chances of it landing with heads up. So that's 2/3. And probability of tails, 1/3. List the sample space and calculate the associated probabilities for each of the possible outcomes. Alright, in the interest of saving time, I've copied the one from the textbook. So P, find the probability distribution for this non-uniform distribution. So we want to find the number of times we have heads. So then 0 heads, 1 head, 2 heads, and 3 heads. So then to get 0 heads, that's the bottom one, which is 1, 7. If you want 1 head, it's the last 3. So that's 6 over 27, which is the same as 2 over 9, because they're both divisible by 3. The next one, 2 heads, are all 4s. So that's 4, 8, 12. So 12 over 27 is 4 over 9. And the last one is 8 over 27. Alright, C, we want the probability of x greater than 1. The two numbers that are greater than 1 are 2 and 3. So then that's 4 over 9 plus 8 over 27. That'll be 12 over 27 plus 8 over 27, which is then 20 over 27.